Morning, YouTube. It's Father's Day. It's a beautiful morning. And Father's Day means I can do whatever I want. And so I'm working on the Anet A6. Today I want to go over the cube sensor. On the Anet A6, probably the same for the Anet A8 and also the A2. GearBest sells this, and it's called the Tron XY sensor. The cube sensor has a very particular problem in that its sensing distance is only 2 to 3 millimeters. And that's the sensor right there. Now there's a few peculiarities about this sensor. It's got a pretty short sensing distance. The sensing distance is probably 2 to 3 millimeters to the metal bed. Now I have this, this is like a build-tack surface, and this is almost a millimeter thick. So my sensing distance from the bottom of the sensor to this is probably about 2.2 millimeters or so. Because the sensing distance is so small on this particular sensor, but it does introduce a little problem with trying to follow the instructions in the Skynet bed leveling sensor instructions, offset instructions, Z offset instructions. I crashed into this bed probably 10 to 15 times following the instructions. Now there's a way to do this, and I'm going to link to a couple of videos that show you different ways to do it. I also wrote some special instructions for this particular sensor for the Skynet. Basically what I did is I took the Skynet bed leveling instructions and I edited it in Word, Microsoft Word. I'm going to make that available for download. It's on the Anet A8 Facebook group. So I'll put a link in the description for that so you guys can grab those instructions. This mount I also grabbed from Thingiverse. I'll put a link in the description for this. The only thing with this mount, and I haven't worked through this yet, is it does offset the X and Y axis a little bit compared to the sensor that they have in the instructions. With that being said, the center of the bed is not where the software thinks it is. As you can see here, I don't know if you can notice, but this is narrower. You know, this distance from the edge to this and from here to here is different. And I have yet to set my X and Y offsets in Skynet, Pronterface actually. So let me pop this piece off the build plate and I'll show you how it works. We'll start there, and then I'm going to show you a couple of easy ways to set up this sensor on the Anet A6, and it's probably the same for the Anet A8. I have no first-hand knowledge, but they pretty much use the same control board. Once you have this set up in Pronterface, I'm going to show you one of the easiest, because your bed level may change, you might crash into a part, things can happen. And I'm going to show you a way to set the Z offset without having to go through Pronterface every single time. I mean, for the initial setup you need to do that, but afterwards you don't need to do that. So what I'm going to do, I'm just going to push this somewhere around the middle of the bed. Now what I like to do is I like to preheat the bed. I like the bed to be on because it definitely changes the shape of the bed. So I'm going to set the bed temperature here. Set the bed temperature to like 70 degrees. That's typically what I print at. So you can see now it's heating up. Heats up pretty quick since I increased the voltage up in this power supply here. I have this cranked up to 15 volts going through a MOSFET. It heats up a lot quicker than it did running on the 12 volts. Pretty impressive actually. You want to make sure your nozzle is clean when you do this. So to manually move the Z-axis, we're going to hit Prepare, Move Axis, Move Z, and at first we're going to go in 1 millimeter increments, and we're just going to twist this down. You can see I'm twisting it down. And when we get about 5 millimeters, when the sensor's about 5 millimeters above the bed, we're going to switch this to 0.1 millimeter movements. That's about 10 millimeters. Let's go a little bit more. Okay, right about there. Alright. So now we're going to hit the button. We're going to go to 0.1 millimeter movements. And now we're going to move it down slowly. Okay? 0.1 millimeter at a time. And what we're wanting to do is keep lowering it till the light turns on. And then when the light turns on, we're going to make a note of what that location is. There it is, 2.1 millimeters. So we're going to write that number down. Now that number, right now it's at 2.1, but when you do this for the first time, it could be 14, it could be 11, it could be 12 millimeters. It doesn't really matter. It doesn't reflect the actual distance. Now we're going to take our piece of paper. I wrote down 2.1 here. Now we're going to take our piece of paper and we're going to stick it under the nozzle, and we're going to continue to lower. And we're going to move this paper until we get the type of squeeze we're looking for on this paper. We're getting close. Close enough. Still lowering. Okay, I'm getting 0.1. Now the only reason why my numbers are pretty accurate here is because this is already set up. Your number might be 14 and it might offset down to 12. So we're going to write 0.1. Okay? So this is the actual nozzle distance, and this is the distance where the sensor senses the bed. So what we do is we subtract these two numbers. We subtract these two numbers. 2.1 minus 0.1 is 2.0. Now, we're going to go back into here, and we're going to go Control, Motion, Z offset. And we're going to set that Z offset, this 2.0. I got 2.10 because I fine-tuned it. We're going to set, you can set that number in here by twisting this. Okay? And the thing is, you got really fine adjustment here too. In 0.01 increments. I'm going to leave it at 2.1. But when you get this number, this 2.1, where the sensor touches, and then where the nozzle squeezes the paper, you subtract those two numbers and you get a number, which is, in my case, it's 2.0. Then you would enter it in Control, Motion, Z offset. Right here. This is where you enter that number. Now, once you enter this number, you hit. Make sure you enter that number as a negative number in the Z offset in here. Make sure you enter it as a negative number. Okay, go back to the main menu. No, right here. Yeah, hit Store Memory and hit Load Memory. You have to do those two things. Now it's stored that number in here. Now your Z offset for your sensor is set. Now here's what I typically do. Once I have that set, I'm gonna put a file in the description. It's a Thingiverse file, and it's a bed leveling file. It's called bed level 160 millimeter. And I'm going to put a link in the description for that. And we're going to print this. And I'll show you what that does for you. Basically what it is, it's a 160 millimeter square this way, and it prints 2 layer heights. In my case, I like to print at 0.2 millimeters. So it'll print 0.4 millimeters tall by 160 millimeters square. And then what I do after it prints is I measure it. I measure the thickness of it. Now before you do any of this, you need to set your bed level as you possibly can, and that's also in the instructions. I mean, this stuff is not a fail-safe, you know. I mean, it's for minor adjustments, right? But you need to get this as flat and as, you know, like a normal bed level. Level all the 4 corners, go around, make sure they're level. Okay, so here we are. We're looking at my computer screen here. This is the original instructions for the auto bed leveling guide in Skynet 2.3.2 Fix 2. And I highly recommend that you use that version. I know there's a newer version out, but it's still in beta. This is the official version for the Anet A6, A8, and A2. In step 9, this is where the Z offset procedure is different. If you use this procedure, you're going to crash your nozzle into the bed, guaranteed. I did it about 12 times, thinking I did something wrong. But the problem is, it's a quirk with that sensor. These instructions were developed for a sensor that had like an 8 millimeter sensing distance. The cube sensor has a sensing distance of only 2 to 3 millimeters off the aluminum bed. So, after much trial and error, I came up with these instructions. And there's a link in the description for these instructions. Now, they're basically all the same as the original instructions. Okay? All the way to step 9. When you get to step 9, you can see I highlighted in red, and this is my wording, my typing. Here is where the revised procedure changes for the cube type sensor. Do not use the following procedure as you will crash the nozzle into the bed. See step 9B. So don't use this procedure right here. Go to step 9B. Okay, and this is all my writing. And there's a description of how to do it. Basically, you lower the Z until the sensor triggers, like I showed you in the video. I do it on the actual printer using the LCD menu of the Skynet firmware. Go to Control, Prepare, Move Axis, Move Z. Then lower the Z until the sensor triggers. If you overshoot, go back up about 10 millimeters and start again. Use the Find Control. Now take a note of the LCD display Z location. Write it down, like I showed you in the video. Now lower the Z axis some more onto a sheet of A4 paper like you're doing a bed level calibration. Once again, make sure you're using the fine setting on the Move Z axis screen, which is the 0.1 setting rather than the 1 millimeter. Once you have the height set right with the paper, just slightly dragging, go back to the home screen again and make a note of the Z-axis height. Jot that number down on a piece of paper. Now subtract the sensor level height from the nozzle height. Should be a number between 4 millimeter and 1 millimeter. Enter this number as a negative number at the M851 command like below. For an example, let's say the number you came up with is 3.01. hit enter, M500, hit enter. Now Z minus 3.01. Now you are ready to actually print the cube. Okay? So I highly recommend you use these instructions. If you use the original instructions, you're going to crash your nozzle. Guaranteed. I'm not the only one that had that problem. And I put a link in the video, and I'm also going to put a link up above for a video that ProjectTube did. And he runs into the same problems at about 16 to 17 minutes into the video. And again, there'll be a link in the description for his video and how he went about setting his Z height. I think my method is just a little easier because he did a lot of trial and error. Okay, so I lost, my battery died on me. So I'm going to continue here with this print. We're going to print this test pattern. Hard to see the black against the black. But right now it's printing out the skirt. When I set up my prints in Cure, I always print the skirt to prime the nozzle. Now it's printing a regular the test pattern. I print this slow because I want accurate results. I normally don't print this slow, but for a test pattern, it's a good thing to print slow to see what's going on. You don't want to attribute. You want to eliminate any problems you might have by going too fast. So what we're going to do now, we're going to peel this up, and we don't want to pull on it, we want to scrape it, because if we pull on it we'll stretch it, and we don't want to stretch it because we want accurate dimensions here. All it is, here, let me get you to a better vantage point. Okay, so now we're going to measure the thickness of this. We got 0.57 on this corner, 0.51 on this corner, 0.67 on that corner. It's actually a little high. Not quite sure why. 0.58 on this corner, 0.60. Now I'm getting good bed adhesion, so I could leave it there if I want to, or I can tweak it. I'm gonna run that again. I'm gonna show you how I tweak the level, so this might be a happy mistake. So because I'm too high by, let's call it 0.2, we're going to go to Control, Motion, Z offset, and we're going to tell the sensor, we're going to tell Skynet that it's we're at 2.1, so we want to go let's go 2.25. That should close the distance a little bit. Alright, we go down here, make sure you hit store memory and load memory. Boom. We're going to do this test print one more time. Go up to the main menu, print from SD card. Go down to my file here. Bed level 160 millimeter. Now when you set this up in Cura, you know, make sure you set your layer heights at 0.2. Set your print speed at like 30 millimeters a second. You know, Cura is a whole different discussion. I'm not going to get too much into that. Plenty of other people have done that. We're going through the auto bed leveling procedure here. I'm going to start printing. I'm going to print a skirt first. I always print a skirt. Make sure you set that up in Cura. That primes the nozzle. Hard to see the black on black. There it goes. Now it's printing that guy. This test pattern is 0.4 millimeters thick. It goes 2 layers. So this first layer should be 0.2 or thereabouts. And then this is the second layer. Now the fan just kicked on. I don't run a fan on that first layer. You want good bed adhesion. Looks better. Let's see what we got here. Ah, 0.45, that's good. And we don't want to pull on this because then we stretch it and then we lose our measurement, you know. I'll scrape it off. Now down in this corner, 0.52. That's pretty darn good. I can live with that. That's 0.1 of where we want to be, but you know, the goal here is bed adhesion. We're not going to cry over 0.1 millimeter off. Let's see what we got in this corner. It feels like it's pretty close over here. Let's see what we got over here. 0.37.